1.5 rational numbers. What are rational numbers? Numbers that can be written in fractional form, that is p over q, shows that p and q are integers. Q not equal to 0 are known as rational numbers. Okay, if you look at here, this is fraction. P refer to numerator and Q denominator. Okay, so means the value of denominator not equal to 0. Recall back what we have learned before. We have learned about positive and negative integers, positive and negative decimals, positive and negative fractions. All that are example of rational numbers. Okay, let's see if you have 3 over 7. So this one is positive fraction, already in form of fraction. So since it is can be written in form of fraction, so yes, this one is rational number. We look at another example. Let's see if you have 0.7. This is positive decimal, so you can convert 0.7 into fraction. It will become 7 over 10. So since it can be written in form of fraction, yes, this one is rational numbers. Another example, let's say if you have negative 12, this is negative integer, also can be written in form of fraction. It will become negative 12 over 1. Okay, so since it can be written in form of fraction, yes, it is rational number. Let's say if you have 7 over 0. This one is a fraction, but this is not rational numbers. Why? Because you can see the value of denominator, okay, the value of q equal to 0. Okay, so this value cannot equal to 0. So since it is equal to 0, so this is not a rational number. Okay, now we look at how to perform computation involving combined operation of rational number. Okay, so we look at example 16. So you can refer in your textbook. So we look at number A. Okay, question A. So you have negative 0.4 plus 1 over 2 times negative 1 over 8. So for combined operations, do you remember combined operation you have to solve using Bodmer's rule. Okay, by using Bodmer's rule, operation inside the bracket you have to solve first. Okay, followed by multiplication or division from left to right, and then plus or minus from left to right. Okay, for this case, you can see all these are rational numbers. You have to convert everything in form of fraction, because rational number is odd numbers can be written in form of fraction. So what you have to do, you have to convert everything in fraction. So let's see if you have 0.4 plus 1 over 2 times negative 1 over 8. Okay, so if you convert negative 0.4 in form of fraction, it will become negative 4 over 10. This one mixed number, it will become 3 over 2. So this is improper fraction times with negative 1 over 8. Okay, after you convert everything in form of fraction, you have to follow Bodmer's rule to solve. Okay, by using Bodmer's rule, is there any operation inside the bracket? So you can see here, no other operation, only negative. Okay, so you move to the second step, multiplication. Yes, you can see multiplication here. You have to solve multiplication. So negative 4 over 10 remain the same. Okay, positive times with negative, you will get negative. Okay, and then 3 and 8 you cannot cancel out, 2 and 1 also you cannot cancel out, so you just times this number. 3 times 1 you get 3, 2 times 8 you get 60. Okay, write in bracket because you have two signs here, positive and negative. Then you remove the bracket. Okay, since it is different signs, so this one will be negative. If the same, positive. Now different, negative. Okay, then you have subtraction here. Okay, so when you want to subtract fraction, denominator must be the same value. So you have to convert into the same value. So you can see here 80. So this one you times with 5, times with 5, times with 8, times with 8. So it will become 80. Okay, 4 times 8 you get negative 32. Negative 3 times 5, negative 15. Okay, no more bracket, no more multiplication or subtraction. Sorry, no more multiplication or division. So you only have subtraction. Okay, so you solve from left to right. This one you will get negative 47 over 80. Alright, so we look at another example. Okay, these are rational number. The same thing, you have to convert everything into fraction. So 18 will become 18 over 1. Okay, times with negative 7 over 12 plus with 1.5. So if you convert into fraction, it will become 3 over 2. If you are not sure, you can use your calculator to check. Okay, 0.3, it will become like 3 over 10. After you convert everything in form of fraction, then you have to follow Bodmer's rule. Okay, everything inside the bracket you have to solve. Okay, inside the bracket you have multiplication and addition. You have to solve multiplication first, then you plus with 3 over 2. So for this multiplication, you can see 18 and 12 both can divide by 6. Okay, so this one 6 times 3 you get 18, 6 times 2 you get 12. Okay, so now what's left is 3 times negative 7, you will get negative 21. 1 times 2 you get 2, and then plus with 3 over 2. You still have bracket, and then divide by 3 over 10. Okay, still you have to solve everything inside the bracket. Okay, addition involving fraction. Denominator must be the same value. For this case already in the same value, so you just calculate negative 21 plus 3, you will get negative 18. Divide by 3 over 10. Okay, since you cannot divide fraction, you have to change this one become multiplication. Okay, change, and then this fraction will become inverse. Then we check 2 and 5 can cancel out. 2 times 1, 2 times 5, you get 10. 3 times 1, 3 times 6, we get 80. Alert with the sign, is it positive or negative? So this one negative times positive, your answer will be negative. And then 6 times 5, you get 30. This one 1 times 1, you get 1. Okay, no need to write 30 over 1. Okay, just write negative 30 now. Okay, this one will be your answer. So please remember, when you want to solve combined operation involving rational numbers, first you have to convert everything in form of fraction. After that, you follow Bodmer's rule to solve. So that's all for today. Thank you.